Hello. So yesterday I had a talk about building a simple Ðapp with Meteor, and there were some audio problems in the beginning, and that's why I want to record this shorter video this time to go through the code again and explain what it does and how I did things, so that other people can benefit from this as well. So I will start sharing my screen. And we basically first explain the basic concepts and how you should start building a Ðapp using Meteor, and some basic concept about Meteor itself. So first off, you should install Meteor, which you can do if you go to meteor.com and you follow the instructions there. And then you would create a Meteor app just by saying Meteor create my app, and Meteor would create a folder for you with some kind of example files. So if we look inside this, we have like 3 files. Ideally, and I already prepared this, you wouldn't put this Meteor folder as your main folder, but if you build an application, it's better to have a top level folder, as I have here, and then the Meteor folder being a subfolder of this, so that you can add any other files like readme, package.json if you use some npm modules, Solidity contracts, or whatever you want to put on top, which you don't want Meteor to manage. So in this case, everything which is in the Meteor folder, everything in here, it's a Meteor application, and Meteor will manage that for you. So it means if there's a JavaScript file, it will automatically put this to your application HTML file and CSS file, so that you have some extra room. Just create your application as a subfolder. So in this case, what we already did is I created this example, and I already added some basic packages and some very useful basic packages, and one necessary basic packages is obviously Ethereum Web3. So you would add that by calling Meteor add Ethereum Web3, and this will add you the Web3 layer to talk to your node over RPC. Other useful packages are my template var package, which allows you to have reactivity template specific, and the persistent minimongo package, which mirrors everything you write into Meteor's minimongo directly to local storage. And if you reload your application, it will get it out of local storage and puts it back into your in-memory minimongo database. This way you can basically very easily persist your data over page reloads in local storage. So we add these 2 things, and we can get rid of these 2 packages, and this basically gives us a very basic application. So I will go also in this application, and we will see it already fully working. So in here we have the app folder, and the app folder is the actual Meteor application. So we go in, we start our development server by running just Meteor on so now we can go to our application on localhost 3000. Actually, I have to pick up my charger. So now I'm back online with power. So this is how the application would look like if it's ready, and I will guide you step by step through all these basic pieces. So basically what the application does, short, it will first show the latest block information. It will show transactions which this contract received. And there's a little game where people can set numbers and then other people can guess these numbers. So the set number would actually modify the state of the contract, and the guess number would just read from the contract, which is free. So this would cost money, and guessing would be free. So to make the application actually work, we have to start our node first. I'm going to do this. So we would have to install your Go node. Following the instructions on the wiki, just Google Ethereum Go build. And I'm doing this on my side. This one. I'm unlocking my account. Yeah, it's unlocked. So if I'm now restarting this, you will also see as soon as there's one block mined, which will take a little. It will generate my DAG. This probably takes a little while, so we will let this happen in the background, and I will guide you through the code first. Okay, so the first step is we will look at the code. So I structured it like this. The Meteor folder we don't have to care about. Meteor basically has the has some folder specific behavior. So if you name a folder client, it will only, so everything in that folder will only be delivered to the client. If you have a folder called server, it's only delivered to the server, and everything outside of these folders will be available in both client and server. For dApps, which purely run in the client, we only need the client part, so we just create a client folder and put everything in there. Additionally, if you have a folder lib called lib, it will load these files in here before the other files. So and I want the contract specific files loaded before the others, so I can use it later in here. If you look in here, I have the contract code, which I used, which is the compiled contract code, which I used to deploy the contract. And then I'm creating a contract object and providing the ABI. This is all done using the Solidity real-time compiler, which I will link also in the description of the video down. So in this case, I just took my contract in here, put it in here, and I get the bytecode and the interface, which you then can use to create your object. But this talk is not talking about how to deploy contracts. It solely shows you how to use Meteor and what is useful patterns to interact with the Ethereum blockchain. So if you go back to this, so we create the contract object, and then we create the instance of the already deployed contract. So guess number at this address, where before I deployed this on my private chain. And then we have the contract instance, which we can use in our application. So this is basically the only variable I really need to have global. Meteor is one condition. So if you have a file and you want the variables to be only available in that file and not globally, you put the keyword var in front of them. Because what Meteor will do, if it concatenates all these files together, it will wrap all these in an anonymous function. And all the variables which don't have var will be attached to the global object, the window object, or the global object in the node environment, and otherwise they won't be only available inside this file. So it means inside the anonymous function. So these three are available globally. You can easily check that if we open the console and we type in guess number, and there's our contract. Or the contract, no, code, available here too. One simple thing to check, actually, if our code exists at this address, is calling web3 eth.getCode and putting in the address, and ta-da, the code is deployed at this address. So the first thing actually what is done is, so it have only 3 simple files. The most smart way of handling the integration of Ethereum into any application, and as well a Meteor application, is to separate everything. So separate the logic from the views. And in this case, even separating the whole logic of the Ethereum connection, so to say, into one file. So this file will only be creating all the filters and talking to the Ethereum blockchain, and then put things into sessions or into collections. And the view itself will only talk to these collections and never directly to any Ethereum stuff. Though there are some exceptions when we send transactions. And then there's a little styling so it doesn't look too ugly. But to go step by step, what we are doing here is we first displaying the blockchain. So one common thing, one thing of Meteor is you don't write a HTML complete file out. You just provide head tags and body tags, and Meteor will find all these in your HTML files and merge them together into one head and one body tag, which it delivers then on the start of the application. And everything else is done through templates, which are wrapped inside template tags, which you can spread across files. But in this case, for simplicity, we just put everything into one file. And you give these templates names. And these names you can later use to insert those templates into other templates, like I'm doing this here. For example, I provide the heading block infos, and I just put this template in, which would be the same as just putting this in here. And each template have its own controllers and events, which are only locally scoped to this specific template. And this current block, for example, is a custom helper I wrote. And you can find this here in the Ethereum example.js. And we take the template blockchain status helpers, and we specify the current block helper. And we're returning a JSON stringifying an object, which is comes from the session get latest block. Session in Meteor is a global reactive object which you can set, which also survives hot code pushes. In this case, we don't have any hot code pushes because our code will never be refreshed from any server, but it's a global reactive object and easy to use and already available. So we on the beginning session set default, set this to an empty object, and then in here, once this helper is run, which is when the template is rendered the first time, this session get latest block gets returned here with some styling parameters. And that's why we see here in the spree this empty object. So if you would write hello, then it would just print out this object with the hello after it reloaded the page, which should happen now. Yeah. Okay, there it is. So the good thing is, this is the logic of the template. This is a reactive object used inside a reactive function, because every template helper function is a reactive function. And therefore, we only need to set or change this session variable somewhere in our code, and it will rerun this function, re-rendering this part of the template and updating this view. Oh, DAG is almost generated. Nice. The question is why it's not updating. My application by default. Okay, so in our Ethereum connector, so the first thing is we want to listen for incoming blocks. Right now there are no incoming blocks because we are not mining, but now we are mining because the DAG is generated. And now this view does update. So we see it set the latest block, and I'll show you in a second how. And it's updating this because the session variable gets a new object set every time there's a new block mined. It will update this pre. So we are at block 15,857. When the next block comes in, this will just change, which should be now. Okay, anyway. So it's a nice way to debug this. And these difficulties, they have an odd representation because they are normally big number objects. And there we go. So the block number changed, another block was mined, and the hash changes, all the information changes. So, and this is done in the Ethereum connector in this upper part here. So if you don't look at this for now, the first thing is we check if the current provider is set. If it's not set, we set our own provider and set it to HTTP provider and on localhost 8545, which is our current Geeth node running, where the RPC server of the Geeth node is running. And then we create web3 ETH filter latest. And this filter is the new block filter. So it will always get notified if there's a new block arriving. And then you call watch, which actually starts the poll cycle to look at this filter of incoming stuff, and it returns you the block hash of the currently new block. If there's no error, we use this block hash to get that block, to get the full block. And we always use the async version to don't freeze our interface. And once we get the block, we just call session.set latest block, and we provide the block. This will change the reactive session variable latest block, rerunning this function and re-rendering the template. And therefore, this just updates on the fly when things are arriving. And this watch is always called if there's a new block arriving. So this callback is provided for that watch. Next thing is these transactions. So we want to see if somebody sends money to this contract, and we want to display this here. So how we do this? First, we have to look at the contract itself. The contract itself is pretty straightforward. Come on. It basically just has a number variable and two events, a deposit event and a set number event. And there's three functions, and one of these functions have no name. Unnamed functions are always called if something is transacted to this contract without specifying a specific function. And this could even be, for example, sending a plain transaction which only contains value and no code. So if I'm sending money to this contract, this function would be called. We are checking if the incoming value is greater 0, and if so, we just call the deposit event with the message sender as the from and the message value as the value. And the money obviously stays at that contract address then. And in the Ethereum connector, we simply use our guest number instance, which is the global object we get through our contract here. We use the guest number instance, call the .deposit event, provide as the first parameter an empty object because we don't want to filter based on specific variables. We just want every deposit event. And a second, we give some filter options. We want to have all logs from block zero to block latest. This includes all new incoming or mined logs. So this filter will give me all the past logs, including then firing all the time if there's new incoming stuff. So we call watch on this as well and provide a callback. So once a log arrives and there's no error, we just spit out that money arrived, log arguments from whom and log value from whom. We have to call .toString10 because the value will always be a big number object. Because in Ethereum, we can have way values, and way values can be very big numbers. So in order that you can do proper calculation without misrepresenting or changing the numbers, we use the big number library, which allows us to work with these big numbers. And if you want to represent them, the best is to call toString10. And then later we will store that in our deposits collection. This deposit collection we created in the collection.js. We simply in Meteor call new Mongo collection, naming a collection, and we say collection now. This code could be in Meteor be run on the server and the client. If you run it on the client, it will create a mini Mongo collection, which is basically looking and behaving like MongoDB, but will be only in memory. So you can query on that, you can update documents, and you can remove documents, but it's basically only in memory. With the addition of the package persistent mini Mongo, you just call new persistent mini Mongo providing deposits collection. It will persist this whole collection directly to local storage. And when you reload the page, it will get it out of local storage. So we have already some transaction stored from before. So you see these three here. If I reload the page, they will always immediately be there again, because it basically pulls them right out of local storage back into my DOM. You can check this if you go to resources, local storage. We see here our, so only look at this piece. So the deposits collection and then these three entries, which is these, and you can here see the values on the right side. All the other stuff is from other applications. So you basically just create this global object deposits, persisted with mini Mongo, and then we use it in this connector here to insert a new document. In this case, we use even upsert. Upsert is update or insert. And we provide an ID. This is done so that when we get logs multiple times, and this is every time we would reload the page, it would give us all the logs from block 0 again, that we don't store any duplicates. So we use as an index this prefix tx underscore plus log.transaction hash. The transaction hash for this log will always be unique. And therefore we use this to identify basically this log. Store it based on this ID in our database and our mini Mongo database, and add the values from a value and store only the string of the value and the block number. And then later in our HTML, we simply have this deposits template. And this deposits template, which is inserted here, uses each, which will iterate over this part, actually over this part, as many times as there's items in this array, and write this HTML, so the from value and block. And the deposits is another helper, custom helper I created, which you can find in here, where you see this is the templates deposits. I don't care about this for now. And we created the helper deposits, and this just makes a query on the deposits collection. Deposits.find, and give me every document which is sorted by block number and order it by block number so that the latest block number is on the top. And the second helper, but to this I have to add that collections in Meteor, like the session object, are reactive. This means once you change one part or one document which you queried somewhere else in a reactive function, this reactive function will rerun itself. So in this case, because we're querying for all documents, if you add a new document to the deposits collection, it will rerun this helper, therefore probably changing the number of returned documents and therefore adding a new each loop to our template. So it will rerun this and update the template accordingly. And the second value, the second helper is called value, which is actually already a property of the document we return. So everything in here will be having as data context one of these documents, which I'm iterating over. And our documents have, as we already inserted before, from value and block number. But in order to override this value, we just create a helper called value2, and we use this value, which is the current data context property value, and we format it nicely with using the web3 from way function. We just say web3 from way, taking in the way value which you stored in the collection, transform it to ether and add the string ether on the end. So, and if we have this in place, and we, through the connector here, just update this database, we have these transactions listed here, 3 in this case, from this address, this amount of ether, and this block number. So, and to test this live, we just will create a transaction. So we call web eth send transaction from our own account 0 to, that's actually a wrong address. So let's go to the contract address and take this one. We send it directly to this contract, and we use the web3 two-way function, and we send 41.55432 ether. So once we press enter, it will send this transaction, but not yet mine it. Once it's mined, it's there. It immediately appears on our screen. So from my address, actually, I sent 41.5 ether in this current block, which is the previous block. So that's it. That's how you can update and live watch for incoming transactions. Basically, just sending money to this contract while watching for the deposit event in here in our contract, which is fired by this anonymous function. So, and to make this more interesting, this contract has the set number function and the guess number function. So set number basically does nothing else than it receives the number and it sets the received number to our number in the contract, and then calls the set number function event. So the set number event is only that people, user or other dApps can be notified somebody set a number, it's time to guess. So in this case, this function actually modifies the state because it modifies its variable of this contract. So this cannot just be called, it has to be transacted to, and it has to, because it's changing the state. So what we do in our connectors code is we just basically watch for the event set number, again providing just an empty object. In this case, we don't even want to watch from block 0 to block latest, but if you provide nothing, it will look from block latest to block latest, means it will only look for the latest mined event. And when an event comes in, it will show us an alert that a new block number was set on this and this block, and that we can try to guess. To make that easy for the user, I created an interface part, just this up here, which lets you guess and let you set numbers. To set numbers, let's first look at the HTML. The HTML is basically this part here. It's this template on the end, which is injected here. This template, the guess number, has basically just a simple input text field. Then it has 2 buttons. which are shown based on the template var.get set number logic, and it has another link which is just a switch. And this is using the template var package I showed you in the beginning, and this basically is an instance specific reactive variable. So what happens in the code, so we have the guess number template, and we look at the guess number template part. In this case, we don't create any helpers, we don't need any helpers, but we created events. And these events will be scoped to the template. So we don't even have to make crazy selectors, just basically saying which button with class is fully enough. So we say, if you click on this switch, we basically set the template var of this specific template instance. And we have called that set number, and we call it to the opposite of when we get the set number. So this is an event, this is not reactive. If this would be reactive and I would do something where I set and get the same thing, I would create an infinite loop, obviously. But this is not reactive because events can't be reactive, only template helpers. So what happens here? We set this thing to the opposite, which means if this is true, it will be false. If it's false, it will be true. And therefore, this is also a reactive global helper from that package, which I created. And we get here the set number object. And if it's true, then it will show this button. And if it's false, it will show this button. And this simple thing just let us switch. And why is this template specific? If I would take the same template and create this multiple times. So now we have 3 times the same template. Meteor reloads, we have 3 times the same template. Looks a little off. Okay, let's make that a little bit more pretty. So that this is really template specific. It doesn't work for all templates, but only for this specific. So let's remove this piece again. Okay, so what happens if I'm pressing the set button? The set button is basically when we press set, we again use the global guess number instance, and we call the set number function of that contract. We provide the value you put in this input field, and again we use the template instance, which is the second parameter, to any event in Meteor. And we just query for the input field, and it will only look into this template, so we can just put an input, and we take the value of this input field, which is whatever number I type in this input field, and then we have to specify from which address we're transacting, which will be my primary address, and provide some more gas than the standard because the execution is probably more expensive than a simple transaction. In this case, I'm providing 15,000 gas. And afterwards, I'm setting the value of 0, so just to remove the number. So, and if we execute this, it will actually modify the state because it will create a transaction to that contract, calling the set number function with providing this value. And if we do that, and we say, let's say 40, set number. Next time this is mine, it will actually modify the state of the contract. And because we are watching for the set number event, we will get a nice alert telling us somebody set a number, which should happen now on the next block actually. Hopefully we didn't comment out. Ah, there it is. A new number was set on block 15986. Try to guess. So now we can switch the guess functionality. And this is not transacting. This is just calling into the contract, immediately executing without modifying the state. So it's free because it's like querying my local database basically. And this is done in the guess. So if you press the button guess, we're basically just alerting this is the current number I put in is, and then we have this function guess number instance dot guess number, and we provide the current put in value. And this function will immediately return true or false if you're right or wrong. So if we say, is the number maybe 20? Then we see 20 is false. If the number is 39, it's false. Maybe it was 40. Ta-da, and it is true. In this case, this is not a very good example of a contract because everybody could simply read the storage of that contract by using Web3 ETH at storage at providing the address, and it's probably at storage position 0. Yes. And we would convert this to decimal. Oh, that's a little odd. It's probably not that storage. But ideally, what I wanted to say is that you should encode this before you store it in any kind of variable. So it's not that easily readable. Actually, this. Anyway, that's actually it. So you can send money to this contract. You can watch for it. You see your latest blocks incoming, and you can guess numbers. And you can set numbers. Yes, so I hope you like it. The code is online. You can, there we go. The code is online and you can look at it yourself. It's pretty little, as you can see, and does already a lot, thanks to reactivity. And what is the nice way here is you separating the whole logic, which talks to the Ethereum blockchain very nicely from all your logic of your views. The only thing where we actually use Ethereum stuff is when we actually call functions or we're sending transactions. Everything which comes in, we just store in our local models and only talk to our models. So it doesn't actually matter how they get filled, where they get filled from. The only important thing is if they're filled, we present it somehow on the screen. So I hope you like it, and we will probably do a few more of these in the future. Thanks, everybody.